The force of wind is a very powerful source, and we have all seen it in action at one point or another, from propelling sailboats across open seas or even turning the blades on farm windmills. Needless to say, this natural element constantly impacts our lives. By the first decade of the 21st century, wind energy has become the best hope for alternative energy. Compared to other alternative forms of new energy sources, wind energy found itself as the fastest growing alternative energy in the world, generating energy to several European countries and the United States. This alternative system of wind energy is actually a form of solar energy created when the sun's radiation heats the atmosphere unevenly, causing air temperatures to vary. The effect of hot air rising to reduce atmospheric pressure on the Earth's surface and cold air descending creates wind currents, along with the help from regional temperature and the Earth's rotation. Europe was the primary leader in this new era of wind development until the beginning of the new millennium, when the US more than doubled its wind electric generation, overtaking Germany as the world's top energy producer in 2008. This multi-billion-dollar industry of wind was once used by ancestors to propel boats, pump water, and to mill flour from grain. It's one of the oldest sources of power used by men that has developed over time and is currently being applied to a new mission, transforming mechanical power into electricity with revolutionary success. When humans first harnessed the energy of the wind, applying it to do work is unknown, but historical wind power was primarily used for transportation. The Egyptians used wind energy to propel boats along the Nile River, innovating linen and papyrus sails as early as 3100 BC. By 200 BC, in China, the simple structure of windmills were being used to pump water. Meanwhile, in Persia, the woven reed sails of vertical axis windmills were grinding grain and lifting water from streams to help irrigate gardens. By 1300, the English post mill was replaced by the more powerful tower mill in the Netherlands. These immovable brick or stone, wooden frames, skyward tower mills did more than just pump water and grind grain. They also drained lakes and marshes in the Rhine River Delta. Fast forwarding till after the discovery of the New World, despite industrialization in America, the advancement in electricity helped to spark the development of wind turbines. Inventor Charles Brush developed the first practical large-scale automatic operated wind turbine used for electricity production. This led to the development of Parmel Putnam's largest wind turbine for the time, formerly known as Grandpa's Knob in Vermont.
Towering above Grandpa's Knob near Rutland, Vermont, the Smith Putnam turbine fed electricity to a Vermont utility company. This system was designed to produce up to 1.25 megawatts of electricity. 1 megawatt equals 1 million watts, or enough electricity to light 10,000 100-watt light bulbs.
After the 1970s oil embargo, which caused concerns in regards to the energy supply crisis, there was a revival in wind energy. Ultimately, the converting of wind energy into useful power has come of age improvements and appeasement in economics, thereby leading us into an age of modern wind turbines. Modern wind turbines use aerodynamic principles to capture the wind's energy most effectively. There are two types of wind turbine classifications in terms of rotor aerodynamics, the first being drag type. That's when the rotor harnesses power from the drag from the airstream, acting parallel to the direction of the flow. The aerodynamic lift has rotors that instead act perpendicular to the direction of their wind flow, but overall work together regarding the turbine. On the other hand, turbines have two basic structures, a horizontal axis wind turbine and a vertical axis wind turbine, with a third new innovation called a tether-based wind turbine. The horizontal axis is a dominant technology in modern wind energy, achieving higher energy efficiency, thereby increasing power production. It has many advantages, such as being a propeller base, having various means of control, meaning that the power output and router speed can be controlled by changing router pitch, router direction relative to wind direction, and blade angles. On the downside, the electricity equipment must be situated right behind the router on top of these towers, resulting in higher energy costs in construction. Vertical axis wind turbines are currently used in small-scale wind farms, the oldest design being the Savonius router. This router was a drag type and is no longer in use due to the lack of efficiency. Following the Savonius router was the Darius router, designed in 1925, being the first aerodynamic lift-type router that was based on the complex shape to maximize energy output, but was somewhat difficult to manufacture. The Darius router then evolved to the H router that has a router tilt for speed control. Although the structure seems simple, it's still not an economic competitor with the horizontal axis wind turbines. Back to the horizontal wind turbine, there's several parts. The router blades, used for capturing the wind's energy, the nacelle, which holds the gearbox, the shafts, the generators, and the brake, along with the tower and transformer. Now let's see how it works. The energy in the wind is converted to the rotational motion by the router. When the blades turn, the router turns a shaft, which transfers the motion into the nacelle. The slowly rotating shaft enters a gearbox that greatly increases the rotational shaft speed. The output shaft is connected to a generator that converts the rotational movement into electricity at a medium voltage. The electricity flows down the heavy electric cables inside the tower to a transformer, which increases the voltage of electric power to the distribution voltage. The distribution voltage power flows through the underground lines to a collection point where the power may be combined with other wind turbines. The electricity may be sent to nearby farms, resident towns, or substations. It is believed by 2050 more than 80% of the energy should be renewable, 20% should be wind energy, and a large fraction will come from wind turbines placed at fields or at sea. Wind farms are a cluster of wind turbines that act as one electricity-producing power station on a large scale. There's a high level of availability that results from the reliability of the machines that is determined by the location. Offshore wind turbines are 40% more productive due to the more frequent winds, but construction costs are twice as much as land-based wind technology. Meanwhile, Texas, Kansas, and Wyoming are the leading wind power producing states out of the 41,455 wind turbines in total in the U.S.
Wind energy is a renewable resource that emits no pollutants or greenhouse gases during operation. It does not require fuel, so there is no mining or drilling needed, as in the case for coal, oil, or natural gas power plants. Sounds like an environmentalist dream, doesn't it? Yet many of the social barriers to widespread wind power utilization are environmental. Some invoke strong emotional opposition by residents near the proposed wind farms. The taller and larger the turbines, the more land in between them. Because wind power is not a concentrated form of energy like coal or oil, it requires large amounts of land, typically 10 to 30 acres per turbine. For example, the DOE estimated that 142,000 1.5 megawatt turbines would be required to generate 20% of the nation's electricity needs. At 20 acres per turbine, almost 3 billion acres of land are needed. However, most of the land associated with wind farms is empty space. It's available for other uses, for example, agriculture, leisure, or natural ecology. In general, the noise levels of large, modern wind turbines are relatively low, consisting primarily of low-pitched rhythmic whooshing sound. Most complaints from residents close to wind farms occur at night when there is no other ambient noises. During the day, other noises tend to dominate. Wind farm syndrome is a term used to describe a variety of health maladies caused by inaudible infrasound. Effects due to noise can be either subjective, interference, or psychological. Subjective effects are annoyance, nuisance, or dissatisfaction. Interferences can be with activities such as speech, sleep, and learning. Psychological effects are anxiety, tinnitus, ringing in the ear, and hearing loss. Some owners, on the other hand, though, welcome noise because it is a sign of prosperity. One positive aspect of new technological innovations is that noise problems with the wind turbines have been reduced along with their new design features. Collision mortality is another problem with wind turbines. Many birds and bats have been killed during migration periods. The large, rotating blades of a rotor pose a hazard for birds, as evidenced by the increased mortality rates of large birds of prey near the Altamont Pass wind farm in California. Over 1,000 raptors die each year and about 67 gold eagles as well. A study estimated that a single wind turbine kills, on average, 10 birds per year. However, comparisons with other man-made hazards such as buildings and glass, vehicles, pesticides, and hunting reveal that wind turbines represent a minor hazard. Bat fatalities are higher than bird fatalities at well-monitored wind farms. Dead bats are turning up beneath wind turbines all over the world. Bat fatalities have now been documented at nearly every wind farm facility in North America where adequate surveys for bats have been conducted, and several of these sites are estimated to cause the deaths of thousands of bats per year. The death of these poor birds and bats is one major environmental problem that advocates for these animals are trying to help solve. Wind turbines cause electromagnetic interference via three principal mechanisms, namely near-field effects, diffraction, and reflection and scattering. Near-field effects refer to the potential of a wind turbine to cause interference to radio signals due to electromagnetic fields emitted by the generator and switching components in the turbine. Diffraction occurs when an object modifies an advancing wavefront by obstructing the wave's path of travel. Diffraction effects can also occur when the object not only reflects part of the signal, but also absorbs the signal. Reflection and scattering interference occurs when turbines either reflect or obstruct signals between a transmitter and a receiver. This occurs when the rotating blade of a turbine receive a primary transmitted signal and they act to produce and transmit a scattered signal. In this situation, the receiver may pick up two signals simultaneously, with the scattered signal causing electromagnetic interference because it is delayed in time or distorted compared to the primary signal. These interferences can be a major problem in society and is why they are one significant environmental issue. Since wind turbines are so good for the environment and do not pollute the air, they are overall better for your health than many other choices of energy. Oil spills are a major problem with petroleum that harms wildlife and animals, as well as all the toxins they emit when driving cars that pollute the air around us. Wind energy is a healthy choice for us as well as for our environment. Development of wind power projects can provide employment and training for many people in different categories. As the wind energy industry continues to grow, it will provide many opportunities for workers in search of new careers. These careers extend beyond the wind farm. It also takes the efforts of workers in factories and offices to build and operate a turbine. According to the AWEA, an estimated 85,000 Americans are currently employed in the wind power industry and related fields. Many workers are found on wind farms, which are frequently located in the Midwest, Southwest, and Northeast regions of the United States. Texas, Iowa, and California are the states leading in wind power generating capacity, but many other states, including Illinois, Indiana, Oregon, and Washington, are in the process of substantially increasing their wind generating capacity. Since taking office, President Obama has been focused on building an energy economy in the United States that is cleaner as well as more efficient and secure. As part of that effort, the administration has taken historic action over the past few years to support the development and deployment of renewable energy that will create new jobs and jumpstart new industries in America. And we are making a significant progress towards the American wind industry that had its best year ever in 2012 with more than 13,000 megawatts installed. In the fourth quarter alone, more than 8,000 megawatts were deployed, an all-time record for the industry and twice as much wind as the previous record set forth in 2009. All of this progress builds on the encouraging trends in renewable energy over the past few years. Since 2008, the U.S. has doubled renewable generation from wind, solar, and geothermal sources, and America is now home to some of the largest wind and solar farms in the world. Wind power currently contributes to more than 10% of the total electricity generation in 6 states, with 2 of these states above 20%.
Ultimately, the converting of wind energy into useful power has come of age through technology improvements and the appeasement of economics, as well as the reduction in environmental impacts. The alternative energy source of wind power is valuable and a vital resource that efficiently continues to power industry and homes.